Hello everyone and welcome to my channel. Today we'll be examining woodpeckers, the architects of the forests. In the dense heart of a temperate forest, a rhythmic hammering breaks through the ambient chorus of birdsong and rustling leaves. It is precise, relentless, and unmistakable. Long before you catch a glimpse of the source, the sound alone tells you that a woodpecker is at work. These extraordinary birds, belonging to the family Picidae, are among the most specialized and ecologically vital creatures on the planet. From the frost-bitten boreal forests of Canada to the sun-drenched woodlands of Central America, woodpeckers have carved out a niche, quite literally, that no other bird occupies in quite the same way. To understand the woodpecker is to appreciate one of evolution's most elegant solutions to the challenge of survival. There are approximately 240 known species of woodpeckers distributed across almost every forested region on Earth, with the notable exceptions of Australia, New Guinea, New Zealand, and Madagascar. They range in size from the diminutive bar-breasted piculate of South America, barely larger than a human thumb, to the magnificent Pileated Woodpecker of North America, which can reach nearly half a meter in length. Despite this remarkable diversity in size, color, and habitat preference, all woodpeckers share a suite of anatomical and behavioral adaptations that bind them together as one of nature's most successful avian families. To watch a woodpecker drive its bill into the trunk of a tree, sometimes at a rate of 20 strikes per second, is to witness a feat of biological engineering that should, by all rights, be impossible. The forces involved in each strike are enormous, equivalent to roughly 1,000 times the acceleration of gravity. For context, a force of just 4 to 6 times the acceleration of gravity is sufficient to cause a concussion in a human being. Yet woodpeckers perform this act hundreds, sometimes thousands of times a day without apparent injury. How? The answer lies in a series of interlocking anatomical adaptations that work in concert to absorb, redirect, and dissipate the energy of each impact. The woodpecker's bill is the first line of defense. Unlike the bills of most birds, which are roughly symmetrical, many woodpecker species have a slightly longer upper mandible than lower. This subtle asymmetry causes the impact force to be deflected downward, away from the brain, and distributed more evenly across the skull. The bill itself is reinforced with a dense, compact bone structure at the tip, backed by a spongy, porous layer of bone that acts as a natural shock absorber. Beneath the skin of the skull lies one of the most remarkable structures in the animal kingdom, the hyoid apparatus. In most birds, the hyoid is a simple, horseshoe-shaped structure that anchors the tongue. In woodpeckers, it is enormously elongated, wrapping around the back of the skull, over the top, and in some species even around and through the right nostril before coiling forward toward the bill tip. This extraordinary tongue support system serves a dual purpose. First, it allows woodpeckers to extend their tongues to astonishing lengths, in some species more than 3 times the length of the bill itself, enabling them to probe deep into insect tunnels. Second, the hyoid acts as a sling, cradling the brain and cushioning it against the repeated percussion of drumming. The woodpecker's brain itself is oriented differently within the skull compared to most birds, positioned so that the larger surface area faces the direction of impact, distributing the force more broadly. Surrounding the brain is a relatively small volume of cerebrospinal fluid, which minimizes the fluid dynamics that contribute to concussions in other animals. The muscles of the neck and head are extraordinarily powerful and work in rapid alternation during drumming. The lower mandible strikes a fraction of a millisecond before the upper, creating a slight mismatch that further distributes mechanical stress. Scientists and engineers have studied these adaptations closely, and they have inspired the design of everything from protective helmets to flight data recorders. Beyond the head, The woodpecker's body is equally well adapted to its arboreal lifestyle. The feet are zygodactyl in most species, meaning 2 toes point forward and 2 point backward, providing a vice-like grip on vertical surfaces. The Picidae family is unique in having an especially stiff, reinforced tail, which the bird presses firmly against the bark to act as a third point of contact, forming a stable tripod alongside the 2 feet. This allows the woodpecker to brace itself against the enormous reactive forces of each strike without losing its footing. The plumage of woodpeckers is typically bold and patterned, often featuring combinations of black, white, red, and yellow. Red and yellow pigmentation is often derived from carotenoids in their diet, and these colors play important roles in mate selection and territorial signaling. Many species display prominent red crests or crowns, which are particularly vivid in males and serve as visual advertisements of fitness and dominance. The woodpecker's relationship with trees is complex and multifaceted. These birds do not simply peck at wood indiscriminately. Their interactions with trees are guided by acute sensory intelligence and behavioral sophistication that has evolved over millions of years. Feeding is the activity most people associate with woodpeckers, and it takes several distinct forms depending on the species and season. The primary feeding strategy is excavation. The bird hammers into bark and dead wood to expose and extract the larvae of wood-boring beetles, carpenter ants, termites, and other invertebrates that live within the tree. To locate prey, woodpeckers do not rely solely on sight. They are capable of detecting the hollow spaces created by insect tunnels through the subtle differences in sound that their tapping produces, a form of acoustic prospecting that is extraordinarily precise. Once a promising location is identified, the bird excavates with targeted efficiency, using its bill as both chisel and crowbar. The tongue then comes into play. Covered in a sticky glue-like saliva in insect-eating species and equipped with sharp, backward-pointing barbs, the woodpecker's tongue can spear, drag, or simply adhere to prey items deep within tunnels. Some species, such as the green woodpecker of Europe, have become highly specialized for feeding on ants and termites, and their sticky tongues are particularly well developed for extracting these insects from their underground galleries. Not all woodpeckers are insectivorous, however. The acorn woodpecker of Western North America has evolved one of the most extraordinary food storage behaviors in the animal kingdom. These birds live in cooperative family groups and spend enormous amounts of time and energy creating and maintaining what are known as granaries, large trees, telephone poles, or wooden structures riddled with thousands of individually drilled holes, each precisely sized to hold a single acorn. A single granary tree may contain upward of 50,000 acorns, and the group defends this resource communally and vigorously against competitors. As acorns dry and shrink over winter, the birds constantly move them to smaller holes to maintain a tight fit and prevent theft, a logistical operation of remarkable complexity. Sapsuckers, a group within the woodpecker family that includes the yellow-bellied sapsucker of North America, take a different dietary approach altogether. These birds drill neat rows of small, shallow wells into the bark of living trees, which fill with nutritious sap. They then defend these sap wells and return to feed from them repeatedly. Sapsuckers have shorter, brush-tipped tongues rather than barbed ones, better suited for lapping up liquids. Their sap wells are not just a private resource, however. They attract a community of other animals, including hummingbirds, warblers, bats, and insects, making the sapsucker an inadvertent keystone provider in its ecosystem. Drumming is another key woodpecker behavior, though it is distinct from feeding excavation. While feeding involves deliberate, measured strikes aimed at particular targets, drumming is a rapid, resonant burst of percussion performed on especially sonorous surfaces. Hollow branches, dry snags, even metal gutters and chimney caps in suburban environments. Drumming serves as a long-distance communication signal, fulfilling the same role that song does for other birds. It advertises territory, attracts mates, and signals fitness. Different species drum at different rates and rhythms, producing patterns distinctive enough for researchers to identify individual species by sound alone. Woodpeckers are also architects in the most literal sense. The nesting cavities they excavate, typically in the dead or dying wood of standing trees called snags, are among the most important structural features in forest ecosystems. A pair of woodpeckers will spend weeks carving out a cavity, and once abandoned, these hollows are eagerly taken over by a cascade of other species unable to create their own. Owls, tree ducks, small falcons, flying squirrels, pine martens, and dozens of cavity-nesting songbird species. In this way, woodpeckers act as ecosystem engineers, their industry benefiting an entire community of dependent species. The diversity within the woodpecker family is extraordinary, spanning an almost bewildering range of sizes, colors, habitats, and ecological roles. The pileated woodpecker of North America is perhaps the most dramatic of the continent's species. With its flaming red crest, bold black and white patterning, and crow-sized body, it makes an impression both visually and acoustically. Its excavations are not delicate affairs. Pileated woodpeckers rip long rectangular gouges into dead wood in search of carpenter ant colonies, sometimes dismantling substantial sections of a tree trunk in a single foraging session. These large cavities, once abandoned, provide nesting sites for wood ducks, barred owls, and even black bears seeking winter dens. At the other extreme, the piculets, small stub-tailed woodpeckers found primarily in South America, with a few species in Africa and Southeast Asia, are so diminutive and so different in appearance from their larger relatives that they can be mistaken for nuthatches or small wrens. They lack the stiffened tail of true woodpeckers and forage on small branches and twigs rather than large trunks, excavating tiny cavities for nesting in soft, rotting wood. The three-toed woodpecker, found across the boreal forests of both Eurasia and North America, has dispensed with one of the standard woodpecker toes, retaining only 3. This adaptation is thought to allow for a more powerful sideways striking motion, making the bird exceptionally efficient at scaling bark to access the bark beetles and wood-boring insects beneath. Three-toed woodpeckers are closely associated with recently burned or insect-killed forests, and they often appear in large numbers shortly after forest disturbances, drawn by the surge of wood-boring beetle activity that follows tree death. In the tropical forests of Central and South America, the woodpecker family reaches its greatest diversity. The lineated woodpecker, a large and striking bird, ranges across much of the continent's forested lowlands. The crimson-crested woodpecker rivals the pileated in size and drama. Many tropical woodpeckers occupy specialized niches in the canopy, foraging on specific tree species or at particular forest heights, contributing to a complex vertical stratification of ecological roles within a single forest. Among the most celebrated and controversial of all woodpecker species is the Ivory-billed Woodpecker, once native to the old-growth bottomland forests of the southeastern United States and Cuba. This enormous bird, the largest woodpecker ever recorded in the Americas, was considered extinct for decades following the destruction of its old-growth forest habitat in the early 20th century. Unconfirmed sightings have periodically reignited hope and debate, but the species, if it persists at all, exists at the very edge of biological possibility. The story of the Ivory-billed woodpecker is, in many ways, the story of what is lost when primary forest is cleared without restraint. Woodpeckers are intimately tied to the health and structure of forest ecosystems. Their presence is, in many respects, a reliable indicator of forest quality. Species that depend on large, old trees and standing dead wood are among the first to disappear when forests are intensively managed, fragmented, or cleared. Conversely, their return to recovering forests is a sign that ecological complexity is being restored. The single greatest threat to woodpecker populations worldwide is habitat loss. The destruction and degradation of old growth and mature secondary forests removes the large diameter trees and snags that woodpeckers depend on for both foraging and nesting. Industrial forestry practices that prioritize the removal of dead and dying wood eliminate the very structural elements that make a forest habitable for cavity excavating species. In managed forests, the deliberate retention of snags and veteran trees is one of the most impactful conservation measures that can be taken for woodpecker populations. In North America, the red-cooperative woodpecker represents one of the most intensive woodpecker conservation efforts ever undertaken. This small social species is unique among North American woodpeckers in that it excavates cavities in living pine trees, specifically favoring old-growth longleaf pine forests, a habitat type that has been reduced to less than 3% of its historical extent across the southeastern United States. Red-cooperative woodpeckers live in small cooperative family groups and may spend years excavating a single cavity in a living tree. They are listed as endangered, and their recovery has required intensive management, including the installation of artificial nest boxes, controlled burning to maintain open pine habitat, and translocation programs to reconnect isolated populations. Climate change presents an emerging and complex challenge for woodpecker conservation. Shifting temperature regimes are altering the distribution of tree species and the timing of insect population cycles, potentially disrupting the finely tuned relationships between woodpecker foraging behavior and prey availability. More frequent and intense wildfires can create short-term surges in habitat for fire-following specialists like the black-backed woodpecker of North America, which is strongly associated with recently burned forest. However, if fire return intervals shorten beyond the capacity of forests to regenerate structural complexity between burns, even these resilient specialists will face pressure. Urbanization, while generally detrimental to forest-dependent species, has proven surprisingly compatible with some woodpecker species. The downy woodpecker and hairy woodpecker of North America, the great spotted woodpecker of Europe, and the red-bellied woodpecker of the eastern United States have all adapted to suburban and even urban environments, foraging on ornamental trees and visiting garden feeding stations. These adaptable species maintain healthy populations even in heavily human-modified landscapes, though they are no substitute for the ecological functions performed by specialist species in intact forests. Conservation efforts for woodpeckers increasingly focus not just on protecting individual species, but on preserving and restoring the structural diversity of forest habitats. Policies that encourage the retention of dead and dying trees, protect old growth and mature forest reserves, and promote the use of controlled fire as a management tool. In fire-adapted ecosystems are all critical components of a comprehensive approach. The woodpecker is more than a bird that hammers at trees. It is a sculptor, a communicator, an insect hunter of remarkable precision, a creator of homes for dozens of dependent species, and a living testament to the power of evolutionary refinement. In the architecture of its skull, the ingenuity of its tongue, the complexity of its social behavior, and the breadth of its ecological impact, the woodpecker embodies the intricate, interdependent logic of the natural world. To walk through a forest and hear that familiar drumming, steady, purposeful, resonant, is to hear the forest at work. The woodpecker is its carpenter, its pulse, and in many ways, its custodian. Where woodpeckers thrive, forests are alive with the full cascading richness of life they alone make possible. And where they fall silent, we are right to ask what has been lost and what remains to be saved. Thanks for watching. Don't forget to subscribe to the channel and like the video. Good night, take care.